Imagine a world without bridges. Rivers would be impassable barriers, valleys would divide communities, cities would be isolated islands. Bridges are more than just structures, they are the lifelines that connect our world. They allow us to overcome natural obstacles, they bring people together, they make trade and travel possible. Bridges have been around for thousands of years. The ancient Romans built aqueducts to transport water. The Incas used rope bridges to cross deep gorges. Today we have bridges that span vast distances. They carry millions of people and vehicles every day. Bridges are marvels of engineering. They symbolize human achievement and ingenuity. Let's start with the simplest type of bridge, the beam bridge. Think of a plank across a stream. That's a beam bridge in its most basic form. Beam bridges are straight and flat. They rest on two supports, one at each end. The weight of the bridge and its load pushes straight down on these supports. It's like balancing a book between two stacks of other books. Beam bridges are the most common type of bridge in the world. They're easy to build and cost-effective. You'll find them everywhere, from small footbridges to highway overpasses. But they have a limitation. They can only span short distances. The longer a beam bridge gets, the weaker it becomes in the middle. That's why most beam bridges are less than 250 feet long. One of the most famous beam bridges is the Lake Pontchartrain Causeway in Louisiana. It's actually two parallel bridges, each nearly 24 miles long. The causeway is so long that for 8 miles in the middle you can't see land in any direction. Now let's step it up a notch with truss bridges. Imagine a beam bridge with a skeleton. That's essentially what a truss bridge is. It's made up of connected triangles. These triangles form a rigid structure that can span longer distances than a simple beam. The triangles distribute the weight and stress across the entire bridge. Truss bridges come in many designs. There's the Warren truss with its series of equilateral triangles. The Pratt truss has vertical members in compression and diagonal ones in tension. The Howe truss is the opposite, with diagonal members in compression. Each design has its strengths and is suited for different situations. The choice depends on the length of the span, the expected load, and even the aesthetic preferences. One of the most famous truss bridges is the Sydney Harbour Bridge in Australia. It's not just a truss bridge, it's also an arch bridge, but its truss design is what gives it its distinctive look. The bridge is nicknamed the coat hanger because of its arch shape. Arch bridges are among the oldest and most elegant bridge designs. They've been around for thousands of years. The ancient Romans were masters of the arch. Many of their aqueducts and bridges are still standing today. The secret of the arch bridge is in its shape. The curve of the arch spreads the weight evenly. It pushes outward at the base into supports called abutments. The beauty of arch bridges is that they can be made from stone. Stone is strong in compression, which is perfect for arch bridges. But modern arch bridges can be made of steel or concrete too. They can span much longer distances than stone arches. The longest stone arch bridge is the Ferry Bridge in China, with a span of 400 feet. But the longest concrete arch bridge, the Danhe Bridge in China, spans an incredible 1,811 feet. One of the most famous arch bridges is the Rialto Bridge in Venice, Italy. It's a single stone arch spanning the Grand Canal. It was built in the 16th century and is still in use today. The bridge is so sturdy that it has shops built right on top of it. Another iconic arch bridge is the Sydney Harbour Bridge we mentioned earlier. Cantilever bridges are like diving boards for giants. Imagine two diving boards pointing at each other from opposite sides of a pool. That's the basic idea of a cantilever bridge. Each side is firmly anchored on land. They stretch out over the water, supporting their own weight. The middle section is usually a simple beam that connects the two cantilever arms. The genius of cantilever bridges is in how they distribute weight. The cantilever arms are usually balanced by counterweights on the shore side. This creates a seesaw effect. The weight on one side balances the weight on the other. This design allows cantilever bridges to span long distances. They're especially useful where the water is too deep or the current too strong for traditional support piers. One of the most famous cantilever bridges is the Forth Bridge in Scotland. It was completed in 1890 and is still in use today. It's an impressive sight with its 3 diamond-shaped cantilever structures. The bridge is painted a distinctive red color. Cablestay bridges are like modern works of art. They're sleek, elegant, and seemingly defy gravity. The basic design is simple. A tall tower supports cables that fan out to hold up the bridge deck. It's like a giant tent pole with ropes holding up the canopy. But don't let the simplicity fool you. These bridges are engineering marvels. The magic of cable-stayed bridges is in the cables. They transfer the weight of the deck directly to the tower. This allows the bridge to span long distances with minimal materials. The towers can be various shapes: A-frame, diamond, single pole, or even inverted Y. The cables can be arranged in different patterns too. Some bridges have parallel cables. Others have them radiating from the top of the tower like a fan. One of the most spectacular cable-stayed bridges is the Millau Viaduct in France. It's the tallest bridge in the world, with one mast reaching 1,125 feet high. Suspension bridges are the superstars of the bridge world. They're the ones you see on postcards and in movies. Think of the Golden Gate Bridge in San Francisco or the Brooklyn Bridge in New York. These bridges are not just crossings. They're landmarks, icons, and engineering marvels all rolled into one. The key to suspension bridges is in the name suspension. The roadway is suspended from massive main cables. These cables run from one end of the bridge to the other. They're draped over tall towers and anchored deep in the ground at each end. Smaller vertical cables hang from the main cables to support the deck. It's like a giant hammock stretched between 2 points. The Golden Gate Bridge is probably the most famous suspension bridge in the world. Its orange towers and sweeping cables are instantly recognizable. The bridge spans the entrance to San Francisco Bay, connecting the city to Marin County. It's 1.7 miles long and its towers rise 746 feet above the water. When it opened in 1937, it was the longest and tallest suspension bridge in the world. Suspension bridges can span incredible distances. The current record holder is the Akashi Kaikyo Bridge in Japan. Movable bridges are like the transformers of the bridge world. They can change shape to let boats pass underneath. There are several types of movable bridges. Each has its own way of opening up the waterway. Bascule bridges are like giant seesaws. They have counterweights that balance the spans as they pivot upward. The Tower Bridge in London is a famous example. Its two halves lift up like arms to let tall ships pass. Swing bridges rotate horizontally, often on a central pivot. The George P. Coleman Memorial Bridge in Virginia is the largest swing bridge in the United States. It opens by swinging its two spans parallel to the shore. Vertical lift bridges are like elevators for ships. The whole bridge deck rises straight up, staying level. The Arthur Kill Vertical Lift Bridge between Staten Island and New Jersey is the heaviest lift bridge in the world. Its 2,700-ton span can be raised 135 feet. Movable bridges solve a unique problem. Floating bridges are exactly what they sound like. Bridges that float on water. They're also called pontoon bridges. They're like a series of boats lined up and connected to form a roadway. Floating bridges are used where the water is too deep for regular bridge piers, or where the bottom is too soft to support them. Floating bridges have some unique advantages. They're relatively quick and cheap to build. They can be easily dismantled and moved if needed. They're also flexible, which makes them good in areas with earthquakes. But they have limitations too. They can only be used in relatively calm waters, and they're affected by tides and water levels. The longest floating bridge in the world is the Governor Albert D. Rossellini Bridge in Seattle. It carries State Route 520 across Lake Washington for 7,710 feet. That's about 1.5 miles of bridge floating on the lake. The bridge uses 77 concrete pontoons. Building a bridge is a complex process that combines art and science. It starts with a need, a river to cross, a valley to span, or a bay to bridge. Engineers must consider many factors. What's the distance to be crossed? What's the terrain like? What kind of traffic will the bridge carry? What forces will it need to withstand? The design phase is crucial. Engineers use computer models to test different designs. They calculate loads, stresses, and wind forces. They consider materials, steel for strength, concrete for durability, or newer composites for lightness.